So in the previous video, we've talked about pandas. We've introduced the idea of pandas as a data manipulation library, and we've also introduced the concept of a data frame, which is the power of pandas, right? So why on earth do we need to do data pre-processing? That's kind of going to be our topic, right? So there are a lot of reasons. In the real world, rarely you get data perfectly formed and ready to be used to solve your problem. Some potential issues could be flaws in the data itself. So you could have missing values, poor formatting, you could just have spelling errors, a lot of things, right? You could have data that's just pretty much irrelevant or redundant. And why do you want to store data that's just a waste? And sometimes you might have a bunch of data sets, so like data sets A, B, and C, and you want to somehow put them together. We want to do all this pre-processing kind of upfront before we actually dive into solving our problem, right? And as a data scientist, data pre-processing takes up a really large chunk of your work. So it's kind of important to be familiar with this. So we have this data frame from the Titanic dataset, which was 891 rows and 12 columns. Let's take a subset of them. So we're going to take these 5 columns here: passenger ID, sex, age, SIB-SP, and parch. And we're going to take the first 7 rows. That way we have a smaller scale of our problem, right? So Pandas really comes in handy through data filtering tasks. So we can isolate certain rows or columns through conditionals, right? So for example, if we want to get all the passengers that are male, well, we want to take all rows where the sex column is male. So that's what this condition is checking. This checking that for a given row, is the value of the sex column equal to male? And if so, we're going to take it. And this syntax here kind of takes all those instances. So this construct is very common in data filtering tasks with pandas. So we take the data frame, but we want to collect only the scenarios where, or the rows where the sex is male. So if we run this, we'll see here that in our sex, you'll see that there's 100% male and deep now, right? So there's no other sexes. So that means this filtering worked. So as a brief exercise, I want you to be able to kind of collect people who are 20 and above, right? So hopefully this should be pretty easy. So I'll give you 5 seconds to think about it. Yeah, hopefully that should be very straightforward. It's pretty much similar to the previous example. So this is what we would do to collect people who are 20 and above. And then we run this. We get the passengers whose ages are 20 and above. So we don't see, in the age column, we don't see any ages that are below 20. So we know that this filter worked properly. So now that we're able to do filtering, right, we can do other things with pandas. So we can remove rows and columns, right? So for example, we can check if we have missing values, right? As we recall, data sets can have missing values. So note that when we're having data, Deep Note actually does provide, like, if we have missing values or not, when we read data frames in, it actually does check this for us. But it's good to know the functionality, right? So this df is null sum goes through all columns, and for each sum, sums up instances where you have NANs. So NANs are not a number, and they're essentially like values you don't want to have in a data set. So we'll see here that age has 177 missing values, and cabin has 687 missing values, and embarked has 2 missing values. So age and cabin are the majority of our missing data. So one naive thing we can do is drop the age in the cabin for simplicity. And we can even drop passenger ID and ticket, as they don't seem very informative. So we can drop this column, and axis equals 1 means drop along the column. So now we don't have cabin, age, passenger ID, and ticket. So we don't have age or cabin anymore, right? So that takes care of that. Another thing we can do is we might have empty values. So you'll see here in the embarked column, so if we scroll right here, we'll see here that there are 2 empty values, right? 2 blank entries right here as represented by 2 others. And there's a difference between blank values and NANs. So NANs are just invalid, not a number entries, and blank values are just what they are. They're just blank entries. So a blank value doesn't necessarily count as a missing value, like according to pandas. NANs really count as missing values in pandas. But blanks are also just important to be able to process. So if you had numerical data, right, one way of dealing with blanks is to just insert the average as a way of kind of filling in the blank value. But if you have a categorical feature, right, you have to do different things. Luckily, the good news is for categorical features, for our purpose of this workshop, we're going to remove entire records that, have a missing value, right, in general, right? So we're going to drop all rows via axis equals 0, where if there's any NaN in that row, we're just going to drop it, period. So when we run this, we will see here that we get a nice data frame, and what we can do here is add a code cell and see what df is null sum is. So df.isNull.sum. You'll see here that we have no missing values.